Okay, what we're going to look at is computing the angles of a triangle given the sides. And what we have here is kind of the application of the law of cosines, which you may or may not have seen before. What we have is the actual formula that comes out of it. If I square the side A, and I subtract from it the square of side C and the square of side B, and divide this by -2 times B times C. I'm sorry, we get the arc cosine, it gives me the angle A. So we have this formula, this squared minus this squared minus this squared. That will give me if I place that into the arc cosine and divide it by -2 times B times C, I get the angle A. And for B, notice I start with squaring B, and then I subtract the squares of the other two sides, and I would divide it by -2 times the other two sides. So the side that's adjacent to the angle determines our formula, or the positive part of this arc cosine. And so all of these are used to determine in radian measure what the angle of our formula what the angle will be for three parts of a triangle. And notice we can make these three separate points. So if we enter point 1, point 2, point 3, they'll form a triangle, and we can figure out the length of the sides. So we're going to make a program that enters point 1, point 2, point 3. 6 numbers to represent 3 points. Then we're going to calculate the length of A, B, and C. And then once we have the length A, B, and C, we'll calculate the angles A, B, C, capital A, B, C. So we'll kind of do this in parts. We'll enter these 3 points. We'll calculate A, B, and C. And then we'll calculate angles A, B, and C. So that's what we're going to set up here. So I'm going to come into Eclipse, and I'm going to right-click on Chapter 4 Projects. Again, I know this window doesn't pop up here. I'm going to create a new class, and I'm going to name it Calculate Angle, and I'll give it public static void main. We're going to need input, so I'll start with inputting my scanner object or my scanner package. Also, because this is going to be a major little bit of a program here, we'll say this is CIS 150 web with Professor Thompson. Here you would put your own name, but I'll put mine. And today's date. And a program to calculate the angles of a triangle consisting of 3 points inputted by the user. So we'll declare our variables. So we'll initialize our variables. So let's see, we will need doubles for x1, x2, x3, y1, y2, and y3, which are coordinates of 3 points. We'll need doubles for length A, B, and C, lengths of sides of the triangle, And we'll need doubles for angle degree measure of angles of the triangle. So we have a space to get everything in. Now we'll need our scanner object. Make sure I'm actually typing this visibly. I have a hard time. And so input from keyboard. All right, so we have everything we need. So what we'll do is we'll ask the user to input 3 points. And I'm going to ask them in order. Enter point 1, X, Y. Enter it. So we'll ask them to enter point 1 as a pair X, Y. And so now we'll say X1 equals input.next double. Get point, get, and X2 equals input X double. And we'll say get points point 1 from user. And now we'll do the same thing. We'll ask the user to enter point 2. Oops, this should be Y1. There we go. So X2 equals input.next double. Y2 equals input.next double. All right, so I'm keeping track of things here. Right now I know what I need to input. I need to input 3 points. And then we'll calculate the size of the lengths between each point. So enter point 3 as a pair. I'm not having the greatest typing day today. And so X3 equals input.next double. And Y3 equals input.next double. Now I am doing no error checking right now. That's something we'll implement in our larger code as we go across. But what I want to do now is I want to compute the sides. And what I'm going to do is I'm going to say that side A is between points 2 and 3. Side B is between points 1 and 3. And side C is between points 1 and 2. This is just to match the way your book does this and the listing it does. So calculate the length of the sides of the triangle formed by the points entered by the user. So side A is between points 2 and 3. So A is going to be a length. So now a length function, you had a program in chapter 2 where you calculated the length. What we're going to do is we're going to use math dot square root, and then inside here we're going to do a calculation, and the calculation is going to be math.pow of x3 minus x2 squared plus math.pow y3 minus y2. Got an extra, there we go, squared. Let's see here, let me make sure I have all my parentheses right. So the square root starts here, and now I need to trap the two math.pows in the square root. Let's see, I have an extra parenthesis there, and I think that should do it. So what we're doing is the difference between the x values squared plus the difference between the y values squared, take the square root. And that was the distance formula that we did. And side B is between points 1 and 3. So B will equal math dot square root. And again, we're going to add the powers of x3 minus x1 squared plus math dot power y3 minus y1 squared. So again, we're using the distance equation to find the distance between points 2 and 3 to make side A. We look at the distance between points 1 and 3 to make side B. And side C is between points 2, 1, and 2. So C is equal to math dot square root math.pow x2 minus x1 squared plus math.pow y2 minus y1 squared. And so now we have all of the sides that we need for a triangle. So we really notice how organizing the variables first, getting the user input, and putting the calculations in separate place has taken a fairly complex formula. If we look back at it again in the browser here, and we've gotten all the inputs now that we know A, B, and C. So now we need to calculate this angle A. And so our focus now is going to be calculating angle A. And then we'll talk about printing good output for this. So we'll need to find angle A using the arc cosine function and these multiplications. And then we're going to repeat it for angle B, and we'll repeat it for angle C. So what we're going to do is we're going to find in degrees. Now this is going to compute it in radians. So we're going to want to convert it to degrees. So let's see. We're now going to calculate the angles of the triangle. So angle A is equal to math dot 2 radians and what we're going to do with 2 radians is we're going to now do this calculation. So if I come back and look at this calculation, I have an arc cosine function of these multiplications with the subtractions divided by this multiplication here. So I'm going to want to do the math.arc cosine and input these. Then I'm going to divide it by the bottom in parentheses because the order of operations and the order the operators are going. So let's put our math.cosine or arc cosine, A cos, and then for A, we needed A times A minus B times B minus C times C divided by, I'm going to separate this down here, and then in parentheses, we had negative 2 times B times C. And a thing about the law of cosines, if you ever take a pre-calc class with me or we see this, is that the angle you want is going to be positive in this part of the side opposite minus the square of the sides against it. And then in this bottom part does not contain the angle at all. And so I just typed all this in and not switching the screen here. So I'm going to come back and show you what I typed in instead of re-recording the whole video to deal with me hitting the button not hard enough that switches screens. So A equals math 2 radians. So what's going to spit out of this is going to be in radians. And so what we want to do is actually probably make it 2 degrees. We like reading degrees. I think that'll be better for us than 2 radians. Yeah, math 2 degrees will make it readable for us. We use the arc cosine function, which does the math we were looking at here. Let's come back. Whoops, here. So the arc cosine of A times A minus B times B minus C times C minus 2 times B times C. So notice that side opposite the angle is the positive part here, and the bottom does not include side A. So we're going to use that to code the next parts. So we'll come back here, A times A minus B times B minus, and so we have our formula in. So let's calculate angle B. Again, we're going to want to see this in degrees. And since we're on angle B, the B will be the positive one. And then it will subtract the other 2 sides. And then we're going to divide it. Again, I'll come down here. And we've calculated angle B. And we'll repeat this for angle C. Math.2. I still switch back to make sure you're seeing the actual program. Again, because it's angle C, then side C will be the positive one. And A will be the negative. and b will be the negative. We'll divide by 2 times the other sides. And there we have calculated our angles in degrees. And what we'll want to do then is we will want to display the results. And what we'll want to do is we'll want to round these, and we'll round them we can either round them to the nearest degree, or we can round them to a nearest decimal point. So I want to start by rounding using the round function. Or we can use a printf. Let's use a printf. So system.out.printf, and we'll say angle A is, and we'll use 2 decimal places. So 5.6.2 F, and make that capital. And we'll say that's in degrees. And I'm going to print it. I'm going to copy the same thing for each. So let's see. We'll also start a new line, so we'll print these out on a new line. So we're going to use a printf. We'll name our angle. We'll format 6 places, 2 of them decimals. And 1 more to go. And so we're using our printf statements here to help us pretty this up. And then I'll close my scanner. And so we should have a working program here. So let's see if this works well. I'm going to make my first point on the origin. I'm going to make my second point along the x-axis. So it'll be 3 down the x-axis, 0 down the y. I'll make my third point along the y-axis, so it'll be 0 on the x and 4 on the y. And I get a nan degrees and negative 3.75. So what have I done calculation-wise? Well, let's look at my calcs here to make sure I am not missing an extra. I have a parenthesis out of place, and this is actually a problem with your textbook here. Let me come back to the textbook. So in the textbook, it has the ACOS divided by this. And if I look deeper in the textbook here, let me scroll down here. If we look at what they do in the program, they do the division inside of the arc cosine. So this is a misprint in the textbook. Arc cosine should have all of these things in it if we're writing it mathematically. And so if we look at the formula we did, I think I will email Professor Ling on that. Because if we look at what the code does, the code, multiplies all of these, then divides by this, then takes the arc cosine, which is an easy fix in our code here. Now, I knew there was a reason I didn't use this textbook version last year. I just did not remember to take note that that was incorrect. All right, so I want the arc cosine of all of this divided. So this arc cosine function needs to contain that, which means actually that goes upstairs. Get some extra parentheses here. I can see why they misprinted it in the book. All right, so now arc cosine contains all of that. And arc cosine is going to, there we have an upstairs, and we divide by the downstairs. Let's see if I can now make a triangle on the origin as 1 point. 3 down the x-axis and 4 up the y-axis. There we go. I made a 3, 4, 5 triangle, and that calculates the degrees properly. This is a good reason why we should run and test our code. And I apologize for the typo in the textbook. I'll make an announcement on that on Blackboard. Again, we kind of completed the listing the book did, but what we did is instead of using rounding, we used the printf statement. Now, I've been introducing printfs, and we'll focus a lot on printfs in this chapter. But what you do is you put in a string, and you have a placeholder with a percent sign for a particular type of variable. In this case, I'm asking for 6 places, including the decimal point, and after the decimal point will be 2. And so what I could do, because of the size of these, is I could actually bring this down to 5. Notice how there's an extra space in my output. Let's try to bring that down. Again, I'll do my 3, 4, 5 triangle. And now we have normalized spacing. And so we have worked with a math program, and we've translated an equation into the math inside of Java. Again, I apologize for the typo in the book. I will send an email out. Actually, we're on the 12th edition. I'll double check because I have a copy of the 13th edition I'm looking to move to see if it's in that. And I should have checked. I should have worked the formula out beforehand instead of relying on what the book said. It did look a little odd to me, but I'm not in that mode in my pre-calc classes right now. I hope that when you look at the listing in the book, and as I talked my way through the listing, I talked about it as us creating it from scratch, not just copying the listing that was in the book. And I tried to logically lay out my code with comments so I could read what's happening through. Personally, there are other ways we could organize this so it would be easier to read. And we're going to see in chapter 6 where we could do methods where once you start repeating the same code over and over again, it might be easier to write a method to do that. And so one of the things to look at is when you see the same commands or statements coming, but the variables just change, this might be something that we want to write into what's called functions or methods.